Why does Linux use a swap partition when the kernel supports paging/virtual memory anyway? As far as I understand paging and swapping, they're completely different concepts. While swapping means that a process is either completely in physical memory or on a hard drive, with paging parts of a process can be in physical memory and other parts can be on a hard drive. But why does Linux need a swap partition then? If the physical memory is full, some processes will be outsourced to the hard drive and a new process will be mapped from virtual memory to physical memory. I just don't get why one needs a swap partition, or swapping in general, then? Or is this just a matter of terminology and swap partition equals virtual memory?
Yes, it is just a matter of terminology. In many cases a swap partition is used as virtual memory. The reason Unix and Unix-like systems prefer swap partitions to page files is that they can be contiguous, which results in lower seek times compared to a page file which may be fragmented.
I don't know where you got the notion that swapping means that a process is either completely in physical memory or on the hard drive. That meaning has not been in use for a few decades. Quoting Wikipedia. Historically, swapping referred to moving from / to secondary storage a whole program at a time, in a scheme known as roll-in/rollout. In the 1960s, after the concept of virtual memory was introduced, in two variants, either using segments or pages, the term swapping was applied to moving, respectively, either segments or pages, between disk and memory. Today, with the virtual memory mostly based on pages, not segments, swapping became a fairly close synonym of paging, although with one difference. Dubious? Discuss. Indeed, in any context involving Linux, or other Unix systems for that matter, paging and swapping are pretty much synonymous. Both refer to a use of virtual memory where the data of page can either be stored in RAM or on disk. A page is 4 kilobits on any device you're likely to encounter. The program using the memory page doesn't care or even know where the data is stored, it just keeps using the virtual address. The kernel transfers data between the RAM and the disk and updates the mu tables as it goes along so that the entry for the virtual address either points to a physical page in memory, or contains a special value that causes the processor to execute some kernel code which will load the appropriate data from the disk. Paging refers to this generic process. Swapping refers to the case where the on-disk data is in a dedicated area, the swap area, a swap partition or swap file. Paging can also be done between RAM and a file, and in this case it's usually not referred to as swapping. For example, when you execute a program, the code has to be loaded into memory to be executed. If a code page needs to be evicted from RAM to make room for something else, then there's no need to write this page onto the swap area, because it can be loaded back from the program file. This can be done for all read-only data, not just program code. If the physical memory is almost full, the kernel looks for a page in RAM, not a whole process, that hasn't been used recently. If that page reproduces the content of a disk file, there are tables in the kernel to indicate this, the page can be reclaimed. If not, the page is written out to swap, then reclaimed. Either way, the kernel updates the entry in the process's virtual memory table, which becomes the mu table while the process executes, to mark it as not in RAM and can then reuse the physical page for something else, a different program, or another page of the same program.
The virtual memory/paging facility lets a kernel virtualize memory to user space processes. The kernel can take pages from physical memory and arrange them through paging so they appear contiguous to a user space process. A limit can be set on a user space process's memory, and if the process goes beyond it, a page fault occurs, which causes a CPU exception which bounces back to the kernel. This prevents the user space program from messing with memory allocated to the kernel or other programs, without the kernel's permission. Typically, user space programs ask the kernel to extend this limit via well-defined interfaces, called by the C functions malloc and free, for example. The kernel is responsible for keeping track of how much and what memory a program is allocated. This page fault mechanism can also let the kernel swap the page the process was trying to access with one from disk, if the kernel is able to over-provision memory, and both Windows and Linux support this, hence why it is called swapping. If the memory access was indeed invalid, i.e. the process is trying to access memory it didn't ask for first, then typically the process will be killed with a 6seg. So swapping is an additional feature. In Linux you can actually disable it entirely if you want. That depends on virtual memory/paging, but isn't required just because a CPU has virtual memory/paging. The concepts are not the same, but swapping depends on paging/virtual memory to exist. Also, after more closely reading your question, paging is sometimes used as a synonym for swapping, but I've never heard of swapping meaning the whole process's memory is swapped out versus paging meaning only part of it is swapped out. But why does Linux need a swap partition then? If the physical memory is full, some processes will be outsourced to the hard drive and a new process will be mapped from virtual memory to physical memory. Virtual memory is physical memory, just remapped. The MU hardware cannot directly map to any storage device. The MU can throw a fault that tells the kernel a process tried to access memory it shouldn't have, and the kernel can use this mechanism to see that a process wants something back from disk that it thought was in memory and then do the swap. The point being, it's the operating system that decides to save pages to disks so it can use those pages for other processes, not the hardware.
In general, swap partition is not equal to virtual memory. Processes can need more memory than actual physical memory, so OS developers decided to assume there is more memory in the system, which is called virtual memory. This virtual memory basically is physical memory and a part of the disk. This part of the disk is called swap in Linux. Also, developers propose that usage of the part of the virtual memory that is located on the hard disk must be as low as possible. For the sake of it, all virtual memory was divided to small portions which are called pages. A lot of pages are used in low rate. These pages must be written out to the part of the virtual memory on the hard disk. This operation is called swap out. The OS must keep track of which pages are not in the physical memory to find them when needed. Page fault happens when a program wants to write/read a part of the memory that is swapped out. To answer your question, Linux needs a swap partition to swap out some pages of memory, and you can see a statistic of virtual memory usage with vstat. The swap column shows swap out and in statistic. Also, this link explains virtual memory and usage of vstat as well.
If you want to support the channel,